Hello everyone, I'm Yoni Harif, Head of Marketing at Worklight, and I want to thank you for joining us for this webinar. As part of the Worklight webinar series, we cover a range of topics that are relevant to enterprise mobile initiatives, from development to deployment and beyond. And today's topic was born out of numerous inquiries we received in recent months as organizations launch mobile apps with a set of requirements far more advanced than we've seen before. So as such, the challenges specifically in enabling push notifications across mobile and operating systems and devices, and whether these are through native or HTML5 hybrid apps, those challenges are becoming more and more complex. Yet the need for such capabilities are increasingly relevant, and this we see across the board. So today we'll be joined by Amit Ben-Shefer, Director of Product Management at Worklight, who will address these challenges and provide a practical approach to overcoming them. Please be sure to submit your questions through the webinar console, and we will address these at the end of the session. In today's session, we will define and discuss the business case for push notifications, review how major mobile operating systems provide the infrastructure for push, with a focus on iOS and Android, and highlight the cross-platform challenges in enabling them across devices, and specifically, of course, as it pertains to the enterprise, and whether that is B2C or B2E or B2B scenarios. And finally, we will share one practical approach to addressing these challenges through the Worklight mobile platform's unified push notification framework. In this discussion, we will also showcase a specific demo example of enabling push and direct you to a module on our website that allows you to do the same. So immediately after the session, you can just go ahead and implement a simple proof of concept around these capabilities and share that with your colleagues. But first, a quick introduction to Worklight. Worklight provides a range of capabilities through a mobile platform that enables organizations to own the mobile process from development to deployment of rich cross-platform apps for smartphones and tablets. So Worklight uniquely supports HTML5 mobile web apps, native applications on the other extreme, and hybrid apps that combine both web-based and native coding. We will not be spending much time on the broader solution of Worklight in today's session, so I thought it's important at least to highlight in broad strokes the main differentiators between our approach and those of others in the market. So first, we are a technology provider focused 100% on enabling unique mobile experiences. And as such, we do not focus on building apps as part of our business model. We believe that if the technology is robust, useful, open, and flexible, then companies can build the best apps for their business. And that remains to be seen, whether via in-house team or a development partner of their choice, or through our vast development partner network. Second, we believe in open standards, and as such have designed and evolved our platform around HTML5. So with Worklight, you are free to add as many capabilities as you want with our open approach. For example, different libraries and tools from third parties. And you're also free to use the range of skill sets and resources that you have within your reach, whether that is HTML, CSS, and JavaScript developers, or whether those are native developers. And you can mix and match, so it's really up to you. And third, we do focus on the enterprise, so whether direct customers, large and mid-market, or ISVs looking to mobilize their offerings. And as such, we support the entire life cycle of the app, including development, delivery, integration, security and management of both the apps and the IT infrastructure to support them over time. So the platform itself is a great fit for consumer-facing, for partner-facing, and employee-facing apps because of the capabilities that we provide organizations with a comprehensive approach. Now, obviously, there's more to it, and we'd be happy to answer any question on the platform now or following today's webinar. And please feel free to reach out to us throughout the webinar and beyond. So, jumping into our topic of discussion. First, we're going to be covering some of the business considerations and use cases for push notifications. Today's session is primarily a technology discussion, but it is important at the outset to ask, why should my organization even consider push? Do I really need to include such advanced capabilities within my app? And I guess the first step is being very specific and defining what is a push notification. So you can see right here in the slide, put simply as Gartner defines it, these notifications or alerts or information pieces essentially relate to an event, which is then pushed to the application on a user's device, quite simply. There is a server-side component, a runtime component to the delivery of this notifications. Different technology pieces play different roles. But a key thing I want to point out in this definition is that the word is the word decides that you see here. The producer decides when to send the notification. So when the event product component sends that notification out, clearly there are numerous ways in which that is triggered. So it can be a bit more complex than simply a direct correlation. And we will go more in depth around that, what triggers the notification. And also note the use of the statement before the consumer component, i.e. the app, knows about the event. So very interesting to keep these concepts in mind during this discussion. So I like to prefer to refer to push notifications as the ringtone of the app. So that's another simple way of looking at it and thinking about notifications. So you want users, be it employees, consumers, or business partners, to use the app effectively. So I think when people talk about push notifications as quote-unquote smartphone version of an SMS or a text message, I think that is not the best definition, and it misses the mark. It's very difficult to cut through the app noise, and so you want a notification that is in many ways visual and audio to alert the user that there is more content and engagement to respond to. And so directing users to your app via notification provides a lot of different benefits for you. Now, there are different components or elements around the use of push for us to keep in mind. So first, as I mentioned, the app, the notification must be triggered. And so that can be the result of an event driven by what the user is doing beyond the app or within the app. Also perhaps via a predefined criteria driven from the back end, and these can be either time-based or data-driven, or it could be any combination of these factors. So typically there are different levels of users also that receive distinctly different notifications driven by certain rules or logic. Second, the type of content that is driven through a notification can be quite diverse. So you can issue the notification that relates to your entire user base, such as alerting that a new company-wide HR memo is available, for example. Or it could be specific to each user after he or she has subscribed to receive different types of alerts. So for example, a banking customer wants to be flagged when exceeding their credit line. Second, the content can be open to all, or alternatively, content that requires only authenticated users to access even the notification text itself, let alone, of course, accessing the app. And even that, you need to consider how lean or lengthy the notification should be. And of course, there's not much room here since you are not using it as a communication channel per se, but still, you can think about the level of detail to include in a notification. Should you include the price of a product, or perhaps just its availability? Should you include a phone number for more details, or just expect people to open the app and get the full scope of the alert? Now, some notifications are time-based, and remember that on certain devices, users can select whether they want to simply see a message that fades out, or some devices enable it to fade out only once the user has performed an action, namely click OK. So that obviously affects also the reachability of the alert to the user. So within this context, you may want to highlight a special offer or a shipping delay, or maybe even an event that has no time cap at all. Now, you also want to be able to think about a notification and consider whether it is actionable or not. So what is the purpose of alerting the user? Do you only want users to consume the notification, or do you want them to respond within the app? Do you prefer for them to act, what I call act outside the app, pick up the phone and call you, or set up a meeting, or conduct a transaction, or God forbid, actually physically step out of their office and walk over to the branch, to the store, to the warehouse, or to the clinic, what have you? Can a simple notification drive that user behavior? That is a good question to ask yourself. So I think so, but it does depend on all the factors and your ability to drive this push within the natural mobile experience that the user expects on their device. And finally, you do want to be able to track how users behave in the app or beyond the app after receiving notifications, and you can also use it as a way to drive feedback and more. So lots of different elements here to consider. Now, I'm only going to provide a very broad picture of the importance of push within a business context, but we could also place an ROI on this simple yet quite elusive component of your app. So for our purposes, we'll just keep it at high level. So I think it's important to look at push as really an extension of user engagement, and that is absolutely critical factor in business success, obviously. So clearly there's a lot of noise out there, and the ability to have that connection with your users is significant. And moreover, push provides a way for you to shape or direct users to act in a certain way that provides them and your company with real tangible value and benefits. So you can actually track these by how users behave following the notification with simple metrics and analytics. So that is obviously on the pro side. Now on the con side, or the challenges, is primarily the result of a cost analysis on how much effort and pain would it actually take to get it done, keeping in mind the constant ebb and flow of the mobile landscape that we're facing today. So just one example, iOS 5. Prior to that release, Apple didn't even have a notification center. So of course, push notifications were still part and parcel of the app experience, but even if your app supported push in previous OS version, that simple change of introducing the notification center could impact the way you want the app to be designed, and its functionality, the type of backend you may want to connect if you want to actually give access to different types of backends. So it really impacts the app's very use case altogether. Now, consider that challenge compounded by the different operating systems and the cross-platform effort that would be required from you to actually support them over time. So that obviously also applies to whether you're focused on native or HTML5 hybrid apps and so forth. So Amit will address these challenges in more detail in a few minutes. Now, there are different scenarios to consider in push. So whether it's business to consumer or business to business or business to employee context. And I've mapped some of these out guided by the impact they have on these four criteria. User engagement on the left here, self-service and productivity, the ability to generate revenue for the business, or to save costs for the organization, not the user. So on this slide, you can see the different use cases highlighted such that the darker the red, the more impact your notification will have within this context. Now, of course, these have impact across many verticals. Some are listed here. So if we focus for a second on the B2C scenario, the column on the left, you can see, you can increase engagement, for example, with a simple content-driven notification, such as a new healthcare plan update, or increase social interactions by alerting that a shopping friend is in close proximity, so you can get a notification around that. Or even the prescription that you've entered is now available, so that creates, a positive engagement with your brand rather than the anxiety and frustration for waiting for your prescription at the pharmacy. Also, you can increase self-service type of engagement. The notification itself only starts the process, so I've tagged it at a lighter red, but still quite powerful. Simple examples would be that your credit score has dropped below a preset amount, or that you need to schedule a doctor's appointment at this time, or that a customer survey is not now available and you can win an award. So different scenarios and use cases. Moreover, you can actually drive revenue from an alert, so that's quite unique. Either by offering a special pricing for a flight that the user has asked to get notifications on, for example, in travel, and that user may still be researching the web, but having that connection can actually make the difference between closing that sale or not. Now, on the B2B side, there are similar use cases for companies working with their suppliers, affiliates, storefronts, or business partners. Now, I'm not going to go through the entire table, but let me just highlight that having, for example, a simple low inventory alert can help drive transaction for you with your different partners within this context. And finally, the case for push is very important for employee-facing apps. You can enhance corporate affinity. You can actually drive CRM, ERP type functionality and impact productivity and much more. So these are just some of the key considerations from an organizational perspective. And I think it has some value in the discussion even before embarking on the technology. But I think at this point, we should assume that you have defined push notification as something of interest to you within your app development effort, and we can explore the technology of it in more detail. So with that, I'd like to hand it over to Amit. And again, please send in your questions at any time, and I can already see some that have come through, and we will respond to them at the end of the session. Amit?
Hi, everyone, and Yoni, thanks. So now that we've gone over the business motivations for pushing notifications to your application users, we can now discuss the mobile push notification frameworks and understand their benefits, their drawbacks, and the challenges associated with using them. And we'll also walk through a quick demo in a few minutes. So all four major mobile operating systems, iOS, Android, BlackBerry, and Windows Phone, have already established push notification frameworks. All frameworks allow application providers to send notifications to specific users. We will focus on push notification frameworks of the two leading mobile operating system providers. That's Apple's push notification service, which is called APNS, and Google's cloud-to-device messaging service, whose acronym is C2DM. So both APNS and C2DM are supported by most mobile devices from these operating system vendors. There are no official statistics from Apple, but surveys claim presence of iOS 4 and 5 on more than 90% of iOS devices. Android C2DM is available since version 2.2, which means over 80% of the Android devices are covered according to official Google statistics. So this means that these services provide very good coverage for both iOS and Android type devices. Well, the first thing that a user needs to do in order to receive notifications is to subscribe to the notifications. Every app that can receive notifications must provide some user interface for subscribing to these notifications. The user interface can list one or more types of notifications to which users can subscribe. Now, once the user subscribes to the notifications, the app performs a subscription process in which the notification service and the application provider must be involved. And only then can the application provider start pushing notifications to the user. Now, once pushed to the user by the application provider, the notification reaches the device and is handled by the mobile operating system. And the operating systems differ in how they handle the notifications. They also differ in how they expose them to the users and what level of configurability they provide to the users in terms of displaying the notifications on the device. So on iOS, to start with, notifications are displayed in a dialog box. They can create a badge on the application icon, and they can also play a sound. In the latest version of iOS, iOS 5, notifications are also aggregated in a notification center, which Yoni mentioned before, and they're available there until the user dismisses them. So depending on how the notification was sent, users can also choose to invoke the application to which the notification is addressed so that the application can take control over the notification. iOS decides how to process an incoming notification based on the status of the destination application. So if the application is in the foreground, iOS will invoke a predefined callback function within the app to handle the notification. And if the destination application is not in the foreground, iOS will display the user interface, whether the dialog, badge, etc., according to the user's settings. Now on Android, the notifications received on the device are displayed by the operating system in a dedicated notification center, whose look and feel depends on the device form factor and brand, as you can see on the screen. The notification is also handled by a background service provided by the destination app. However, unlike iOS, the service should not display intrusive user interface, such as a modal dialog box, because those can interfere with other concurrent user activities. So here is one difference between the user experience across the two mobile operating systems. On the technical level, when the user taps the notification, Android wakes up the destination app and invokes, again, a pre-configured callback function for the application to handle the notification. If the app is in the foreground, when the notification arrives, it can handle the notification immediately, very similar to what happens in iOS. So this user experience brings some important benefits for application users. So first, because users have to manually subscribe to notifications prior to receiving them, they have the control in their hand as to which notifications they receive. Secondly, mobile push notification frameworks deliver notifications also when the application is not active. So this means that users do not have to use an app to receive notifications delivered to it or even to remember to start the application. So users can be assured that they will receive the notification regardless of whether their application is active or not. And thirdly, mobile push notification frameworks can efficiently manage the interaction between the device and the vendor push server. Thereby, they reduce the CPU usage, the battery usage, and the communication requests that were performed if each app would query its servers on a particular basis. From benefit and user experience perspectives, mobile push notification frameworks provide very similar benefits. However, they greatly differ from each other in the underlying technical level. A notification over the Apple network can be no longer than 256 bytes long. Google, on the other hand, allows for bigger notifications and accepts up to 1 kilobyte. iOS provides out-of-the-box support for displaying the notification in a dialog box, playing a sound, and setting a badge on the app's launch icon, while Android does not allow the notification to display a modal dialog box, nor does it provide out-of-the-box support for an application icon badge or sounds. However, application developers can implement that if they wish within the context of the application. Now, both services allow pushing a message to a single recipient and do not allow pushing a message to multiple recipients. It doesn't mean, of course, that you cannot push the same message to more than one user, but you have to do that on a one-by-one basis through your server. You cannot ask the push notification service to deliver the same notification to a series of addressees, to a batch of addressees. Now, as of quality of service, while both APNS and C2DM are provided free of charge for application providers and users, both provide very limited service level. So both services remember only one message per application per device when the device is offline or is not capable of receiving notifications. So in other words, if you send multiple notifications to a device and the device is not ready to accept your notifications, only one of them will be received when the device becomes ready. On APNS, you can specify expiration date for your message if it is not delivered until a certain point in time. Now, from delivery tracking perspective, neither of the two services guarantees the delivery of messages, nor do they allow you to receive a delivery notification, check the delivery status, or cancel a previously made notification. Now, regarding putting limits on the number of notifications, Google sets a regular quota of 200,000 messages per day, but it also allows developers to ask for additional quota through their website. Apple does not mention any specific quota. They only describe that their service as a high-speed and high-capacity service. Both APNS and C2DM use JSON to format messages pushed through their services. So this is very nice from developer perspective. They use different syntaxes, but more importantly, the underlying communication link is different. So C2DM provides an HTTPS URL to which servers can use HTTP post to send a message and receive a response. And APNS provides a high-speed streaming secure TCP/IP connection with binary content. So developers must write the code for implementing this link or acquire an existing library that does that already. Both services ensure the authenticity of the communication. Apple does so by requiring the TCP/IP connection to be secured with a certificate that was provisioned by Apple to the developers. And Google requires developers to declare the server identity with a dedicated Google account and the applications to declare that account when registering for notifications. Now, when failing to deliver, each service mandates different behavior. APNS requires the server that pushes the notifications to periodically query a feedback service. And the feedback service returns the device tokens to which notifications should no longer be sent. Usually this happens because the app unsubscribed to a notification or it was uninstalled by the user. Google, on the other hand, provides such feedback per push request and expects the server to delete the device from the list of devices to push data to. In addition, Google requires servers to implement an exponential backoff mechanism when trying to connect to the C2DM service and receiving an HTTP 503 response from the server. Now, with regards to protecting the notifications sent over the push services, both services require to send notifications over SSL, as we saw before. However, neither of them describes the measures taken to protect notifications within the service network. So you can't really assume that messages you push through Apple's or Google's services are protected in any way. Despite of bringing a lot of value, push notifications are also limited and should be used wisely. So first of all, there is no guarantee on the delivery of push notifications, and we just discussed that before. Users can always inadvertently sign out of receiving push notifications or even disable push on their device to save battery. And in addition, the push services do not officially commit to any level of service and do not guarantee delivery under any terms. Now, another obvious limitation of push notifications is that the notification size is relatively short, 256 bytes for Apple and 1 kilobyte for Google. And lastly, neither of the push services guarantees that the entire delivery chain is secure. So pushing notifications with sensitive user information is probably not appropriate. Now, one way to overcome such limitations, if not fully, is to use the notification framework just to notify the app that something has changed, and then have the app actively pull the new information from the server. Now, since the app server link can be fully encrypted and is not limited by size, the mechanism easily overcomes the last two limitations of size and security. And of course, you can always consider falling back to an alternative delivery notification, such as SMS or email. These mechanisms may provide higher delivery chances, but are not coupled to the application and cannot invoke it. And they may also incur costs, unlike push notifications. So far, we discussed the benefits, user interaction, and technical aspects of sending and receiving push notifications. And we'd now like to talk about the Worklight Platform and how it helps developers and organizations to implement push notifications from corporate services to mobile apps. So let's briefly go over the Worklight architecture first. This consists of 4 parts. Number 1 on the screen, on the top left side, is the Worklight Studio, where apps and backend adapters are developed. Just below it, number 2 on the screen, is the Worklight Server, which is the gateway between the applications and the enterprise systems. Number 3 is the device runtime components for enabling on-device functionality using HTML and ensuring smooth app performance and more. They are also already available for native applications, not only for hybrid applications. And finally, the Worklight Console, this is number 4, which provides an administration interface for apps and infrastructure for user reporting. So for our discussion, I'd like to highlight the parts that are directly relevant to pushing notifications to mobile apps. Worklight's runtime libraries provide applications a unified API for subscribing and receiving push notifications. Apps can also rely on the Worklight server's authentication integration framework to identify users prior to subscribing them. Once a user subscribed, subscriptions are automatically collected and stored in the database of the Worklight server. And they are then available for the Worklight adapters, which are server-side entities that obtain corporate data and can then push them to devices using a unified server-side API. Developers use the server-side and client-side APIs by coding adapters and applications in the Worklight Studio. And administrators can manage and monitor the push notification chain by integrating with the Worklight server and by using the Worklight console. Now, diving in specifically to the push notification framework, the Worklight push notification framework makes it very simple to subscribe to push notifications, push them to users, and handle them once received in the app. The framework is very flexible and supports various notification scenarios. It is also highly scalable and can be deployed in different types of network topologies. The framework consists of client-side and server-side components. On the client side, the framework provides unified JavaScript API for subscribing to push notifications. The API is also available in Objective-C and Java for native iOS and Android applications. But of course, the JavaScript API is the same on both iOS and Android. It uses the mobile operating system to obtain the push notification tokens for the device and registers the app for notifications with these tokens in the Worklight server. The server then automatically saves the subscription data in the database. It also saves any custom notification properties that the application developer has chosen to add. And these properties can then be used later by the adapter when pushing notification to the various applications. On the server, developers can use Worklight adapters to obtain push notifications from corporate backend apps. Depending on the availability of this data, developers can choose whether to actively pull data from the corporate backend using polling adapters or to expose a REST API to which the corporate backend can fire events. In the adapters, developers also write code that extracts the destination user from each notification. They can also rely on the notification state database to get the custom subscription data and use it to filter notifications from the backend or to format them correctly. Then developers use the unified push API to submit the notification. This server-side API uses the subscription data, which was stored by the server when the user subscribed to notifications, and then automatically sends the notifications to the user's devices. Now, the push APIs automatically push the notification through the appropriate dispatcher. When the notification arrives to the device, it is handled by the mobile operating system, which will invoke the application or ask the user to interfere depending on the operating system and its configuration, as we saw before. So now let's see how this works in a real example. We'll go over the example used in the Worklight training module for push notifications. The source code and setup instructions are available on the Worklight website, as you can see on the screen. So you are welcome to try it yourselves. We will not see a live demo because of limitations of this online webinar technology, but we'll see a sequence of screenshots taken from a real app that was set following the instructions in the push notifications training module. And the demo actually consists of 4 steps. First, we will log in from the demo app to the Worklight server. Secondly, we will subscribe from the app to an event source exposed by an adapter in the Worklight server. Then we will send a real notification to the Worklight server and push it over Google C2DM to an app. Of course, in most real-life scenarios, notifications are pushed from corporate applications. But in this demo, to make setup simpler and still to have full control over the entire notification chain, we'll use our app also to send a notification to the Worklight server. And lastly, we will receive the notification in the app after it was pushed to the Worklight server, through the Worklight server via C2DM. So now you can see the main page of the example app. Each button corresponds to a different API method provided by the Worklight runtime on the device. For example, the is push supported button invokes the API that tells you if the Worklight push notification framework can run on this particular operating system. And it will return true for Android 2.2 and above, and for iOS 3 and above. Now, clicking the login button displays an authentication screen in which I type my credentials. Now, logging is necessary in this case so that when I later subscribe to the notification, the Worklight server can associate my subscription with my device and with my username. In real-life scenarios, logging can be performed using any authentication method, not only a simple username password form. And notifications can also be driven to unauthenticated users where relevant for simpler app scenarios, as long as users are uniquely identified in some way. Well, the next step is to subscribe. So after logging in, I subscribe to the notification sources, which are exposed by the Worklight server. Now, behind the scenes, the Worklight client runtime registers a callback with the operating system to receive the notifications when they arrive. It also notifies the Worklight server about the new subscription. You can see the log line in the server's console indicating that the subscription command was received by the server and performed. Now, in this simple example, the server exposes only one event source. However, in real-life scenarios, the server can expose as many event sources as you wish, and the app can display a list of such event sources to the user and let the user decide to which event source he or she wants to subscribe. Now my application simulates a backend application and allows me to send a notification to the server. The server receives the notification, and in this example, it goes over the list of subscriptions and sends the notification to each one of them. You can see the log line in the server indicating that the server found my subscription and is pushing the notification. Now I leave the app and wait until the notification arrives to my device. This usually happens instantly. You can see that when the notification arrives, Android adds an indication in the device's status bar. The notification icon is defined by the application, and the badge number, which is 1 in this case, is set as part of the notification payload by the server developer. When I open the notification center and tap the notification, Android invokes the addressed application in the registered callback. So in our example, the app simply displays an alert with the notification details. Okay, so we just saw a full notification cycle geared by the Worklight platform. Let's see in greater detail how Worklight drives the subscription process in the application. So for a user to subscribe, the application must have the user log in, or at least have in hand a unique identifier for the user, such as in the case of a traveler who wants to be notified of an airport gate change, while the app provided by the airline does not require users to be registered. So in this case, an airline ticket ID would be sufficient, although it's not the classical user ID. The login process can be done using the Worklight authentication integration framework, but it is also possible to log in the user directly via some login service, if this makes sense for a particular application. Once the user logged in, the application should use a Worklight API for checking if the device is ready for subscription. The API uses the relevant mobile operating system to determine this. Then the application can check all data sources and can allow the user to change his subscription status. The application will present the data source with custom user interface, but will change the subscription status using a Worklight runtime API. The API sends the request for creating or removing subscriptions to the Worklight server, which in turn automatically updates the subscription database and allows developers to write custom code for notifying the backend, if necessary, upon changes in subscriptions. Now, when a notification arrives to the server from a backend service, it should be pushed to the device based on the previously collected subscription data. So first, the Worklight adapter obtains the notification from the data source. This can be done over any communication protocol like REST, SOAP, JDBC, or JMS. Adapters can call the backend or wait for the backend events. They can receive the notification one by one or in a batch, and in this case, developers can write custom code in the adapter to separate the batch into distinct notifications. Developers can then write code in the adapter for formatting the data obtained by the backend into a notification text, and can set the badge, sound file, and specify the dialog box for iOS notifications. Then they should write code that extracts from the notification the identity of the user to which the notification should be pushed. Once having this identity, developers use Worklight server-side API to automatically push the prepared notification to all applicable devices of the user. Or alternatively, they can write code for selecting subscriptions in detail and customize the list of target devices. So let's now discuss some complex use cases that are characteristic to real-life scenarios. More and more people possess more than one mobile device. For example, a phone and a tablet. And of course, these devices can be of different vendors. They often install the same apps on more than one device they possess and subscribe to the same notifications from those devices. Now, as we saw, the Worklight push notification framework enables organizations to automatically push notifications to all devices to which the user subscribes. However, some organizations want to employ different logic and push notifications to users based on other criteria. For example, to the device from which the user last logged in. So for such cases, Worklight provides special APIs for accessing the user's subscriptions and deciding to which device the notification should be used. In addition, Worklight exposes the subscription database and enables organizations to manage the subscriptions themselves if they want to. Organizations will consider that if they already have a system for managing notifications to users, usually by email or SMS, and want to extend this system to manage also mobile push notifications. The considerations for creating event sources are usually governed by backend integration constraints, while applications are usually created according to functional or marketing requirements. So this means that the mapping between event sources and applications is usually many-to-many. As such, in many cases, an app can receive notifications from more than one event source, or the same event source should trigger notifications to multiple applications. Developers can make apps subscribe to any event source, and in the server they have complete flexibility to decide to which apps to send a notification. In other cases, a single stream of data from a backend app actually contains logically separate types of information. And in this case, developers can add custom subscription properties that can identify the type of required data. And the server can use these properties to direct the notifications from the common event source as needed. And the last scenario I'd like to cover now is where multiple users log in to the same application. In this case, different users may log into an application installed on a device, such as different family members or a storefront salesperson and the store manager, and each user can subscribe to notifications. Worklight can be configured according to different scenarios, for example, to enable the app to display only notification of the last user who logged in. Now, the Worklight push notification architecture supports clustering to cope with high-speed notification traffic. Multiple Worklight nodes in the cluster can process data from the same event source regardless of underlying communication protocol. Each node opens a separate communication protocol with APNS and C2DM and uses the same credentials to fully exploit the capacity of the APNS and C2DM services. As you can see, this architecture is very scalable and is also very simple to manage and configure. And finally, before moving to the Q&A, in addition to scalability, some organizations may have additional security constraints that mandate a particular network topology. Consider, for example, an organization that forbids a computer to send outgoing requests and receive incoming traffic from the same zone. Such organizations allocate separate network zones for each communication direction. So in such cases, it is possible to install a separate Worklight server in each zone, or one server or cluster responsible for receiving subscriptions from mobile devices, and another server or cluster responsible for sending the notification to the devices. The communication between the servers is done by sharing the subscription database, so one server updates it and the other one reads it. This ensures that the push server uses the freshest subscription data and that users receive only the notifications they subscribe to. Okay, we've covered quite a bit of ground and addressed the business case for mobile push notifications, cross-platform challenges, and how to overcome them. So I'm sure you have lots of questions, and let's try to address these now in the Q&A session.
Thank you, Amit, and thank you everyone for sending in your questions. Feel free to keep sending them. We do have a few minutes to take some of the questions. So the first question is, is it possible to enable push notification for mobile web?
Okay, for mobile web applications are not considered downloadable applications by iOS and Android, and these cannot receive push notifications. So if you want to use push notifications, you must have either a native app or a hybrid app. Of course, the hybrid app can be extensively developed using web technologies, but it cannot be an application that is accessible through the browser. It must be a downloadable application.
Okay. Here's another question. How does the Java server, for example, WebSphere, I suppose I mean IBM WebSphere, work together with the Worklight push notification server? The S&D has a preference for data sources for notifications to be maintained by their own Java server and then rely on Worklight server as a middleware for these notifications.
The Worklight server can read notifications from corporate data, no matter on which these corporate services, on which application server or these corporate services are hosted. So it can integrate with corporate applications using HTTP, SOAP, REST, JMS, directly through the database using JDBC, regardless of the actual implementation of the corporate app. It can be hosted on WebSphere or another application server. It can be a .NET application. Worklight is agnostic to this. Now the server itself can run on a Tomcat application server or on WebSphere, and the push notification logic is part of the Worklight, is encapsulated within the Worklight server. It's part of the Worklight layer, so it's not part of the underlying application server. I hope this answers the question.
Great, yes. And by the way, we do have on our website more content around how we integrate with WebSphere and the solution we offer around WebSphere in general, around mobile apps. Okay, I think we have time for one, possibly two questions. Is it necessary to gather the device token to deliver a push notification?
The device token is critical for delivering the push notification. The device token is the identity, is the piece of information that identifies the device by the push notification service. When a device subscribes to a notification, the actual device ID. I mean, when C2DM or APNS want to deliver a notification to the device, they do not use the standard device ID like UDID or the IMEI, but they use the device token. By the way, the device token can change inadvertently. I mean, APNS and C2DM can decide at any point to provide a new token for the device, and of course, the push server needs to track these changes and always use the latest device token for each device.
Excellent. So last question that comes in that we can address in this session, and the rest we will follow up after the webinar, and we have quite a few to follow up on. When is an application considered quote-unquote ready to receive push notifications?
From technical perspective, there is an API, a service by the operating system that actually provides a device token for the application. Once the application calls this service and receives the answer from this service, then the application can be considered ready. This is an asynchronous service, and this is why it's not a simple API call. But again, these complexities are very much hidden from you by the Worklight API, whether it's the JavaScript APIs or the native APIs.
Okay, great. Thank you so much. And thank you, everyone. We're just out of time. I would refer you, first of all, to the links you see here on the website where you can download a free evaluation version of Worklight for 30 days and try it out. And specifically, the second link, which refers to the online training, does refer to the module that Amit's just showcased, and you can, in fact, implement right now as a proof of concept of the unified push notifications. So I hope this was useful, and we look forward to having you participate and take part in future webinars. Thank you very much.